Let me know.
Anytime you're ready.
Welcome everyone. So today we're going to talk about the crux of the cloud app threat landscape. So in this talk, we're primarily going to look at the enterprise cloud apps, and we'll go for different attack surfaces, abuse cases, and stuff like that. So this talk is primarily based on the research we have done for the last 2 years and come up with different scenarios and stuff like that, how you can exploit the cloud apps and things like that. But first of all, welcome everyone, and thanks for attending this talk, and hopefully for the next 40-45 minutes, we'll make it a really good journey. So just a little bit brief background of mine. I'm doing research for a couple of years now. I drafted this book, which also got picked up by in Chinese as well, so it's translated to Chinese as well. But anyhow, before moving further, I want to lay a little disclaimer in the context, like whatever the research we're going to talk about doesn't relate anything to specific employer or anyone. And the reason for that is just because we are sharing the research with the community, and we're going to make sure that people understand for educational purposes and everything. You have some questions down the lane, it's a learning aspect, but it's more about what's happening in the world of the cloud apps. So that is where we are going after during this talk. So look into the threats into the cloud application space. So if you look at these taglines and all that, news articles, it talks about, what the problems that we are facing in the context of cloud applications. When I say cloud apps, I'm referring to Box, Dropbox, Google Drive, Amazon, and similar set of cloud apps. Mostly they're deployed in enterprises as well, and the individuals are also using it. So if you look at all these, taglines, you can clearly see, it is being covered in the media, several exploit cases, attack surfaces revolve around these cloud apps as well. So where we stand. So there are many cloud apps out there which are susceptible to abuse. When I'm saying abuse, like a couple of the functionalities that these cloud applications provide, those can be abused as well. Further, there are exploits available, which means that if you can find vulnerabilities in those cloud apps, you can also use to launch different set of attacks. But in reality, it is happening, isn't it? Let's take a look. So if you look at this, statistical analysis, it was one produced by Gartner earlier. So look at the breaking of the year by year, like 2016, 17, 18, 2019, 2020. I mean, this is exponential, right? And the usage of cloud apps are going at exponential rate, and which is true as well, right? Because nobody's like trying to store data on their hard disk, like other stuff. Everybody's like pushing the data to the cloud. All the vendors are coming with the scenario with like indirect way of forcing you to actually just go and upload your data in the cloud itself. There are pros and cons associated with that, but again, we are living in the world of cloud these days, and it is still going to grow for the next couple of years before we come up with new set of technologies. But let's take a look. So this actually shows that what kind of cloud applications, one or the other way, we are looking into it. Office 365. Look at the Microsoft is exploding in every sphere. Google Drive, Dropbox, whether we are building infrastructure as a service platform, PaaS, platform as a service platform, or software as a service. Everywhere cloud is playing a significant role. But for us, we are targeting only application space in this talk. But if you look at this sphere, this is real. One or the other way, your end devices are connecting to the cloud apps. Data is moving from one place to the another, hopping on a different channels, and that's where we are. And that's where the world is going through. But the caution here is that if the devices are getting exponentially, triggered up and all that, at the end of the day, we are talking about billions of devices, right? And which means that attack surfaces are going to increase at exponential rate as well. And for us, as researchers, we need to understand how the attackers are going to abuse these platforms as well. And we'll take a look into it. Now let's just move forward. And I'm going to talk a little bit about the threat actors, try to actually, present a platform where we're going to talk about, how different threat actors can go ahead and abuse the cloud apps, different set of things, right? So we talk about, erroneous employees, people making mistakes. Example will be, broadly sharing the files to someone which is not even entitled to do. Or your administrators are not putting set of controls in the enterprises where they just go after, okay, this file, if shared, will be shared among all the employees of the organization. That is happening. Malicious insider, you never know, disgruntled employee can do anything, excessive download of the files from the cloud apps, deleting files and stuff like that. But more importantly, attacker, which is not inside the organization but sitting somewhere remote, and then they are actually going after the enterprises or organizations by attacking cloud applications. So we'll talk in detail a bit about it, and which will highlight what it is all about. Let's take a look into the cloud application threats and attacks. When I say threats and attacks, we're going to use some set of taxonomy where we're going to talk about different set of attacks in that context. And understanding the taxonomy is very, very much important to actually tie the attacks together, and then actually gives us the broader view why this happened, how this happened, and what is the solution to go ahead with it. Let's take a look. So basically, as a part of the targeted cyber attack space, we categorize into four basic blocks, right? Anything that has to be exploited, things like that, there is somewhere infection needs to be triggered, which means that either you have to compromise the device or you have to compromise certain kind of things in the general sense. But when it comes back to the cloud applications, you need to make sure how you're going to infect end users by using cloud apps as a launch pads. We'll talk about it more detail with some, examples and demonstrations as well. From infection, we go to command and control, which basically once you get exploited, how it's going to be managed, the cloud applications which are compromised or user accounts on them. Lateral spreading, which means that, can you use again as a cloud as a launch pad to distribute different set of, malicious documents on the fly. And data exfiltration, I want your data. So this is the kind of basic taxonomy we're going to use, and we'll dissect one by one with different set of attacks targeted specifically on the cloud applications. And that's the way it is. So let's just take a look into what we're going to cover today. And since we are, entirely relating this talk primarily on the application sphere, I won't go much detail into the man in the browser, man in the cloud attacks, but we still touch on those topics to cover the broader sphere. So when we talk about infections, one of the, advanced attack that comes to play is drive-by download attack, right? What it means that, you get a phishing email, somebody is forcing you to click a link, it will go somewhere, it's in the browser, vulnerability gets exploited, payload is downloaded, and then the attack happens and the compromise is there. But we need to understand what are the different variations of this attack that can be triggered by the cloud apps. We'll take a deep dive into it. Command and control, how can you use the functionalities of certain cloud applications to actually build a command and control channel. Then there's the data exfiltration, cover a lot of use cases studies that we have gone through, we worked with the vendors, making sure those guys actually eradicate those scenarios. We'll talk about some real world case studies there. Then cloud apps vulnerabilities, inherent insecure coding practices that actually lead to the compromise one or the other way. So let's get it started. So first we'll start with, a little set up a base with the drive-by variants. The very first one we categorize is a direct malware distribution. But there are three variants. We'll go one by one, and I'll show you how from the basic, the advanced attack can happen. And then we'll have a demonstration to show you how it works. So we talk about direct malware distribution, relay attacks, and in-client drive-by download. Let's first start with the direct malware exploit distribution. Several of the cloud applications, they claim they have a built-in, antivirus protection in place. They can still scan for the files. But some of the camouflaging techniques you can also use to bypass that scenarios, and which is possible. And we'll take and show you some examples on that front as well. So let's take a look. Let's first understand the drive-by download attack to actually set up the baseline from world, So take a look, you got a phishing email in the form of Gmail or some another email, there's a link associated with it. It is taking you to some cloud app, let's say Google Drive, let's say, Box, Dropbox, anywhere. In the file, linked to is a kind of PowerPoint file or any Office file, right? Somehow at that level, when that is triggered, you redirect you to a certain set of file. I'm not sure if you've seen that earlier, but take for example of the Dropbox, right? The Dropbox has this kind of binary check implemented, like, 0 or 1, right? So what it means that either it can ask you whether you want to download a file, or by changing the flag from 0 to 1, you can automatically download the file on the system. Other cloud applications doesn't allow to actually go after and render these files directly in the browser. So what they say, okay, download the file, then execute it on your system, which is fine as well. But what happened in that case when you don't have a visibility there, you're not able to actually render the file in the browser one or the other way, whether it's a plugin or an add-on, then you actually download the file. Once it is downloaded, it automatically says auto run functionality, triggers, and then you got infected one or the other way. But in this case, the only thing that you have done is just click the link, right? Everything else is just a forward mechanism that was triggered, and one thing relates to the another. Now, because we're talking about the cloud apps, I think the beauty of the system plays here is what needs to be happened there as a part of the security mechanism when the file was hosted on the server or downloaded from the cloud apps and things like that. But that is the basic drive-by download attack. We'll go into the variations of this. So very first thing is that, you can host malware directly on the cloud applications. When I say camouflaging, which I mean so that you have an executable file, you change the extension, right, through JPG or any kind of image file, it's still there. The question is that whether the cloud apps are actually, as an example, whether they're actually scanning it appropriately, or they are just saying after, okay, I checked the extension, it's a JPEG file, I'm done, you can stay. Size limits, right? Most of the malware that has been distributed in the world, right, they are shorter in size because they want to make sure that the payload is restricted, constrained, and then it can be easily sent via packets, via HTTP traffic and all that. Let's just take a look at a couple of examples and things like that. Some of the functionalities that we want to really look into when we're doing some threat analysis around cloud apps is that how the URL is shared, right? How it is generated, whether they have some kind of binary checks implemented where the user doesn't have to actually click on certain things on the cloud app, but by default, the file gets downloaded onto your system. So all these things really help attackers to lower down the attack surface. So if you're looking at this particular example, as I mentioned, the binary check, you can clearly see that there's a Dropbox 1, right? And then from there onwards, it comes as once you actually change the flag from 0 to 1, you can clearly download the file without interaction. So which means that just click it, it's only going to get downloaded to your system without providing any kind of notification on the Dropbox itself. So maybe it's a part of the functionality, but it can be abused in one or the other way. So what that attack was entailed to, it was actually spreading the Apache ransomware at that point of time, right? It was on the Dropbox, and then once it gets downloaded automatically in the system, your system gets infected. Again, the important part is that you can claim that, okay, the end user system is infected, but the most important part in that context is the attack is routed via cloud app. So what cloud app vendors are doing, what kind of security solutions you need to be there to actually circumvent this attack. Another interesting scenario, Amazon has 3 buckets, right? What you want to do, this is one of the thing we were analyzing, found in some of the Chinese malware there and all that, executable files and stuff like that. And then it can be directly included one or the other way into different attacks. And then these files can be downloaded on the fly. But caution is that it's still stored in the Amazon S3 buckets. Another example of the scareware, right? Which means that, calling scams that happen on the fly, this kind of, malicious pages, one or the other way, used for social engineering and other kind of set, can still be hosted on the S3 buckets, right? And then, different kind of attacks can be triggered. So this is a few examples that we are talking. We're going to continue, give you more flavor of the direct malware distribution. Again, this is an example of Office 365, OneDrive, where it talks about Android malware, and then they host it, there, and then you can do different attack, mechanisms here to actually, build a full attack vector out of it, but it's still staying on the OneDrive. Nobody's picking it up. Another example in Office 365 is that, okay, you have an attachment of malicious document, like a docx file or PowerPoint file, Excel file, whatever it is, right? And then started sharing directly to the other users in the enterprise as well, right? Because it is attached to the Office 365, have some advanced techniques implemented to bypass the filters, and then you feel like it's good, and then you broadly shared it, right? what kind of solutions you have in place to actually prevent that broadly sharing of files and things like that. We'll talk about it a bit later, but these are the real world case studies that we have found. Another, this is a European-based, cloud service called the SugarSync, right? So we detected a couple of malware families there as well, and then you can clearly see, you dissect it, you can clearly see, there are a lot of indicators that actually point to that. Those are the cases. Another one is like, Dropbox was hosting the Zeus bot, right, earlier in the timeline, and still being used to distribute and build the botnet directly from the cloud app, right? The problem here is that, with these kind of things, people have a trust factor with these cloud apps, right? Oh, the link is in a box, it can be malware, or it is with the Dropbox, can be that bad. But exactly that is not the case. With some advanced tactics, these things can be circumvented and can lead to a different attack vector. So few of these, examples were actually targeted against, the direct malware distribution, which is kind of pretty basic as well. But let's take a step ahead. Relay attacks, which means that you can host some sort of, application code, whether it's an HTML or JS, like JavaScript code on the cloud app. And then whenever the phishing attack happens, the link goes to the cloud app, but the malware is not hosted on the cloud app. It's simply acting as a hop channel. So the JavaScript code will be running there in the backend because certain cloud applications allow that. And from there onwards, you'll be redirected to the malware-driven website. And interesting point in that case is that, again, trust factor, you feel that, okay, I'm still going to Google Drive, I'm still going to S3, I won't be having any problem. But again, at the end of the day, the link is redirecting to somewhere else. So relay attacks, right? In this case, cloud app is simply a hop channel. But when it comes to threat intelligence, we have to dissect, we have to build threat models like this. Direct malware distribution, relay attacks. And now the question is it possible to have your HTML code, JS code, malware code, everything placed into the cloud app and then trigger an in-cloud driver download? It is possible, and we demonstrated that. So in relay attack, as I mentioned, simply, HTML web page, JavaScript has to be there. It has to be made publicly available so that, it can be included into the attack. Because if you're not sharing the file that is publicly available, you cannot use it in the broad set of attack and things like that. Or even in a targeted attack, because you have to include that file so that it can get stranded, so that you won't see like 403 forbidden. So this is an example of how the relay code, which is an obfuscated one, looks like. So this is an evaluation function. I think you guys have gone through the JavaScript deobfuscation scenarios. You can clearly feel this is a Dean Edward Packard, the basic Packard. And then once this code runs, and you can clearly see what it's gonna do, it's gonna go back to, again, to googledrive.com somewhere. This was an example we used earlier, but there are many cloud apps that can be used for the same set of attack. So now we will talk about in-cloud driver download, the most advanced one, right? In this case, the scenario is this one. All the four metrics need to be there. The cloud storage app need to host HTML web page containing JavaScript as well as. Malware is also uploaded on a cloud app with the camouflage techniques, making sure that the cloud apps won't scan it. Then JavaScript, which is going to run in the system, is going to include that file which is still on the cloud application itself. And all you need to do is that you have to just provide the link to the cloud app. That's it. And everything's gonna happen in the cloud app itself, the way you design it, and your system gets infected. And this is the third level, which I call as like advanced drive-by download attack, because in this case, you don't have to put only direct malware, you don't have to put only relay code, but you have to put all things in a place, a kind of hybrid attack. But this is sustainable. Let's take a look, and you can examine yourself about the attack. Okay, so this is one example of the Google Drive one we don't want to use because after this attack is not possible on Google Drive. The reason for that is Google deprecated all the HTML and JavaScript functionality. But this attack can be triggered out on the other side of cloud apps. So that's why we're showing this thing. So let's say in the phishing email, you got this link, right? So this link is going to somewhere Google Drive, right? You think it is authenticated, social engineering attack, but it's still going to a trusted cloud app. But exactly, let's see what happened. You click the link. I have put up these notifications in between just to let you know what is going on the back end. So the JavaScript code is executed. You clicked it, okay. You got to this web page. And there you see you got infected. So we use the Zeus bot sample, which can be easily detectable. But even in the real world attack scenario, you won't be even seeing that notification. You just click on the link, it's done. You got infected, and when you have like different advanced techniques, then you can also bypass the antivirus as well. And let's go into it. So this is a Zeus bot, which was hosted on the app. You can clearly see the header, MZ header, which is an executable file. And when you render the file, it looks like this. But this attack won't work on Google Drive right now because they have chopped off all the other functionalities. But as I mentioned earlier, you can test this kind of flavor of attacks on all the other cloud apps, which still provide supporting JavaScript and HTML. So this, I simply refreshed it. JavaScript gets triggered again. It is showing you how the JavaScript is creating a frame. And then you do it again. In this frame, this is just a one, so you can clearly see the Zeus got downloaded onto your system, executed, but the antivirus picked it up. But you can remove all the other things, notifications, stuff like that, simple and stealth. Just click the link, everything's gonna happen via cloud app, and you are infected. Well, sorry, there was the attack case for the in cloud drive by download. So let's take a few examples that we have seen earlier, and other researchers have also talked about it, like command and control operations, right? Which means that certain cloud applications provide services or functionalities that can be used as an indicators by the attackers to build a command and control channel. What it means by that is, if your end system is infected and then there is some communication needs to be happen with the command and control server, it will be relayed through the cloud app. So the attacker has some mechanism set up in one of the compromised account in the cloud app, and from there onwards it can go there, right? Rather than the end user is hitting the command and control server directly, it's gonna hit the cloud app, check on some of the functionalities, and then attacker will able to figure it out what's going on. So it was like, I think 1 or 2 or 3 years earlier, one of the first variant was the Macadox malware, but we did find plug extract that was like, distributed through Dropbox and several of the other scenarios. But this is a kind of very advanced level, so it can also be boiled down to the scenario which we discussed earlier, like cloud apps as a relay channels. And you can have like some code sitting in between so that people believe, okay, you are hitting the cloud apps, but indirectly you are sending certain signals to that cloud app, which is being picked up by the remote attacker for command and control operations. Now, as earlier we talked about taxonomy of the targeted cyber attacks, you can clearly see how basically cloud applications are fitting inside those buckets like infections, command and control, and things like that. Similarly, as a little bit more details about that, how the proxy channels were created using that malware. It's a little bit, old variant, but we haven't seen precisely now a lot of attacks where the command and control channels are created using cloud apps. But there were few, but when we talk about volumes of attacks, there was not exactly there right now at the moment. So let's take a look into a couple of the data exfiltration scenarios. We have talked about phishing earlier, where the case was to infect the systems. Here phishing was triggered, whereas the target is to actually take your credentials out, right? Because in this case, you can be fooled by a social engineering attack and you can provide your credentials, but everything is hosted on two variants can happen in this case as well. First, where the phishing web pages are hosted on the cloud app, or they have actually mimicking the same behavior, same view of the cloud apps, and then hosted somewhere and then embedded one or the other way into the attack channel. So this was one of the first example. You can clearly see, these came out. The very first one we analyzed earlier. The second one was like where they were talking about exploiting the SSO functionality. Somehow they are able to actually because let me explain a little bit in more detail, because most of these cloud apps work in via single sign authentication these days. And once it is done, there are different set of accounts that are integrated as a federated identities into the same pool, right? So you get through SSO, you get into it, then you have like some another small accounts created for some other services that can be also be accessed right away. So there was some flaw in there where they exploited this functionality and able to, actually inject add-on into the browser, which actually doing some kind of data exfiltration and other scenarios. But let's take a look at the another example for the, because this one is very critical these days and need to be understood in a little bit more detail. And the idea for that is Amazon AWS, as the most used infrastructure as a software service platform at the moment. And the challenge with that is that you need to access the console where you are spinning your VPC, you're spinning your instances in the VPC, how VPC peering is done, a lot of functionalities. Sorry. It all happens via the AWS console. So if somebody is able to trigger the social engineering attack or phishing attack and able to get your credentials, then you can clearly see your whole app, either cloud apps or whatever, your whole infrastructure is compromised, because you can do a lot of things. And we have seen these kind of attacks in the wild right now. Where they have come a one or the other way and spin up instances on the fly. And then you see that cost is growing up because those instances are either being used for like nefarious activities like mining and other kind of things, or distributing malware as well. But another example, we're going to deep dive into the Adobe cloud, right? We were doing some research and we want to make sure that, because Adobe has this like on built-in cloud, how attackers are going after it. Of course, phishing. But we came across certain, remote servers where we're able to get an access and all that, and where we discovered these kind of scenarios. So let's take a look into one of the another. I think there's some. Sorry for that. So we were able to get access to this server, and we were analyzing, because this one is using a lot of different, hosting malicious web pages, and we came across this one, like Adobe Document Cloud, and we were like a bit interested, like how this phishing attack is carried out. So this one is HTTP Fox add-on, and the basic turf across this attack is that it's very simple. They're gonna social engineer you. They're gonna say like, if you really want to access any document on the Adobe Cloud, you need to provide the credentials. So this is how it is all carried out, and we were just doing some testing, try to understand, how the whole workflow of this phishing attack is working. But these kind of attacks are happening at very rapid pace. So you can clearly see it is redirect to the po.php. All your credentials went on to that remote server, and then there onwards, they are just redirecting you to the same page or some kind of fake document that is hosted somewhere. And we are seeing instances of these kind of attacks at an exponential rate these days as well. And this is just not only one cloud app. Office 365 is like also targeted a lot these days, considering because the volume is so high, every single other organization has been now either forced to, or they have moved to the Office 365 scenarios, and where your Outlook is used. So you can clearly see all the credentials got routed to po.php page, and that's how this attack was. It looks pretty neat in the sense the way they have constructed the scenarios, but this will keep on going on. And now let's take a look into the another one. It's still a phishing one, but I really want to give you a flavor of it as well, because we are seeing these kind of scenarios as well. Office 365 SSO identities with set up with the SAML and all those kind of things. And again, we were able to actually got an access to one of the remote server. We were doing some analysis, and then let's take a look at this attack as well. So this one is like some of the compromised domain and all that, and then there onwards. Entirely the complete replica of how the legitimate Outlook page looks like Office 361, but they have made some changes where they're going to redirect traffic back to their attacker control domain. It looks legit, but when it is like, embedded with some other kind of iframes and all that, it becomes very realistic in that sense. But if you see here, the whole attack that is carried out, it is redirecting the same way, same things, and then it's gonna extract your credentials. Once it is gone, then your accounts can be compromised. Now the question is very simple. How many users were able to identify that these kind of attacks are not legitimate, right? And of course, people who are very security savvy, they'll figure it out one or the other way, but there will definitely be people who are gonna fall for it, right? And nowadays we have already seen enterprises are triggering simulated phishing attacks and all that. But even if you see the results, you still find people that fall to those kind of attacks one or the other way. But this is all happening in cloud app space and all that. So I want to talk a little bit more detail about on the data exfiltration scenario, and we're going to tie back with the threat attackers. Like we're talking about erroneous employees making mistakes. If you look at this particular example, it's like an international exposure. You can clearly see we get an access to this one couple of Excel files and all that, which has already username and passwords into it, right? And the interesting scenario is that you have a username and password. It was belonging to one specific organization somewhere, and you are able to access their Gmail accounts because those were not having a kind of SSL in place at that point of time. So again, in this case, I don't think the attackers need to go after finding very kind of advanced flaws in the cloud apps, right? All they can do is to start the fuzzing approach. We'll take an example, look into the example as well. Try to figure it out, these docs, and start analyzing what is already available on the internet, right? So easy. Another interesting scenario, as you can clearly see, one of the marketing agency, they disclose all of their username and passwords to different websites on cloud apps as well. Invoices. For example, if you're living in the world of business competitiveness, right? You got on a list to the one of the biggest firm, which are actually, providing some services to an entity on an organization, and then disclosed all the invoices. You can clearly see what amount is going to be there. And then if you're going after the same client, right, you can actually pay a lot of, interesting scenarios there as well. But again, all that is possible because they are not securing these documents on the cloud apps, right? Whatever the issues are, whether erroneous mistakes or disgruntled employee or attacker is doing that, these things are happening. And this is the one of the tests we conducted earlier. You can build Google Docs, or you can use certain set of tools. In this, one of the first example, we targeted Amazon S3 buckets. I think this issue has been talked a lot. We released some of the blog posts on this front as well. But if you look at this scenario, so you constructed Google Docs and certain things like that, and then you run it continuously by using some of the Google API earlier. And you can clearly see you started getting links of all the PDFs, other files that are publicly available with certain kind of patterns. Let's say I want to see, give me the list of the files which have username in it or password in it. And similarly, with the S3 buckets, right, you can actually start fuzzing on the fly, which actually gives you the idea what kind of buckets you are finding in the East-West region or in the Gulf Cloud region, depending on the availability zones and how the S3 buckets are being deployed and all that. But in this case, attackers are not doing anything extremely different. What they are going after is that what is already available on the cloud apps. I want to have some intelligent tools. I want to build them some scripts. I'm going to go after these cloud apps, publicly available documents, or the kind of stuff they have exposed on the internet. And I think that makes a lot of difference because the more you want to spend time on finding vulnerabilities in certain scenarios, if you actually start with this kind of reconnaissance kind of scenarios or fingerprinting scenarios, I think you can get a lot of information. Information actually boils down to the visibility. In any attack, if you want to conduct any successful attack down the lane, visibility is the big key, which actually comes from the information. And you can clearly, once you trigger these kind of activities, the fuzzing on the fly, I think you can get a lot more out of it, and which is kind of pretty interesting. And we found it, we reported it to the vendors and all that, they acknowledged it, they removed those scenarios. But I think this is a recurring problem because humans are involved in there as well. Now, I also want to talk a little bit in the context of exfiltration as well as infection, but we'll talk about exfiltration there. So when I completed my PhD, it was completely revolved around man in the browser attacks, how these, malware installed in the end user system circumvent the integrity of the browsers, right? These days, cloud apps are mostly accessed via browser itself, right? You go to app.box.com or any other one. You provide your credentials in the browser via browser. Session is created. You can access your files if you are not using the client itself. In that case, when we talk about man in the browser, which simply means that, system is compromised. It can be any drive-by download attack that we have discussed earlier. The payload, the malware is running in the system, and it is waiting for you to open a specific cloud app, right? For example, any, cloud application, Box, Dropbox, and all that. And as soon as you put your credentials in and submit the form button, right at the same point, the malware is actually monitoring the low-level APIs in the browser. So it sees that, okay, you access that app. Now there onwards, you're providing credentials, and then it suddenly implement a hook into it, which means that anything that's going to route it directly to the web server going to write via the detour that is being created by the malware itself. At that point, it can steal your credentials, give it to the command and control server, and then your account is compromised as well. But the little bit is this is more on the compromise that is happening in the end user systems rather than the application itself. Similarly, man in the cloud, this was a variant again came in where again the malware installed on the end user system actually steals your tokens from the client that you have set up, because okay, you have this particular folder that is being shared. You just upload the file or put the file in that folder, it's synced back to the cloud app. There onwards this kind of attack, but this is more focused on the compromised systems and all that. But these are also used a lot, but I think man in the browser is being staying here for the last couple of years and it's gonna stay there. But again, once it is there, it can exfiltrate data one or the other way, basically your credentials, user behavior and things like that. And from there onwards, they can build additional set of attacks. Now, we did some research on this part as well. We talk about cloud application, vulnerability exploitation, because, you have this, different cloud applications. They are created in such a way. Then you can also find some flaws in it. And again, as I mentioned earlier, attackers basically abuse the trust element you have with it, right? And then if you find vulnerability in these apps, right, they can be very, very disastrous in that sense. So there is a couple of you we highlighted here, several cross-site scripting, OAuth misconfiguration in one of the biggest cloud app provider, and that was a really a bad one. Design flaw in one of the cloud app provider website, SSO issues and all that. Just this because a part of the responsible disclosure research, I cannot name the cloud applications where we found these vulnerabilities, but they were patched earlier because under those guidelines, we have to report them to the vendors. But again, from the exploitation point of view, you find a vulnerability, try to work out how you're going to carve a full attack out of it by exploiting it one or the other way. And we did provide, the use cases and the way how it can be exploited to those vendors. But now couple of these vulnerabilities have already been patched and fixed. Now, I think I just want to do a little recap. We started with, why cloud is booming, what are the threat actors in the cloud application space. And then from there onwards, we set up the one simple taxonomy of targeted cyber attacks, talk about infection scenarios, talk about command and control, data exfiltration, and things like that. And then we discussed several of the cloud application attacks, for example, direct malware distribution, in-relay attacks, in-cloud attacks, command and control attacks, how attackers abuse the functionalities of the cloud apps to conduct those operations. And then we look into several real-time use case studies of data exfiltration and all that. And we understand the problem, but where we stand with respect to the enterprise security at the moment, right? Vulnerabilities exist, abuse cases are there, how cloud apps are being abused, how attackers are going after these attacks. But I really want to touch on the topic of window of exposure. I think it is a very important topic but I think we should touch a little bit, and then I think we are almost getting to the end of our journey here. So I put it in this way. So let's take an example. You have a sensitive document that is exposed via cloud application, right? So at that time T, the document is exposed, which is containing sensitive information. The window of detection is the time taken by any solution or an individual to actually detect like that document is exposed. And from there onwards, the time taken to actually fix that issue comes in the window of prevention. So when we talk about window of exposure, it's the window of detection as well as the prevention. It doesn't make any sense you detect an attack, but then you didn't do anything. You can't prevent an attack without having visibility on the fly, right? So that actually entails to the window of exposure. Two use cases arise in this scenario. And the one is that if you are not able to detect it at the right time, or you are not able to prevent it at the right time, the attack is still gonna be there, one or the other way. And then if you are doing one and not doing the another, then it's also a problem, which entails again to the point, the one point you detected an attack, you have to build your scenario of prevention right there. Detection alone doesn't lead anywhere. It's always a hybrid approach that you have to follow to do it. So you have to reduce the window of exposure, which is done by multiple scenarios. But again, at the end of the day, if you are able to minimize that window of exposure, that's how you're going to tackle the attack. That's how you're going to circumvent those attacks, by reducing the exposure. And this can be mapped back to any attack scenario. Any attack scenario, you can use this concept to build the scenarios. So we talk about now window of exposure, but a little bit, going after some of the mitigation and prevention strategy. I think Chris earlier mentioned as well, there's nothing, one gold shot out there. What it's all about is that it's always an hybrid approach, right? People can say that, okay, machine learning is an answer, artificial intelligence is the answer. But I can still bet like majority of the vendors still use signature and heuristics as a part of certain indicators to feed your algorithms, which uses machine learning and all that. You just cannot avoid signatures. You just cannot avoid heuristics. You can minimize them, but then you still need them to build up a full sphere and then map it back to your algorithms to get a bigger picture rather than staying on a one small point. So that's the point of like auditing, detection, and prevention all matters, right? Auditing, you just get a feel of visibility. Detection, you have algorithms running. You can fetch the data from your auditing components, and then you build some detection algorithms which kind of detect certain kind of things, but then you need to have policy enforcement, prevention scenarios as well. How long it will take, it depends on how good the platform is, right? You can have a simple solution, a box sitting there, okay, we can detect an attack, but you're not helping us to prevent an attack, which means that you want that box to get integrated into your existing solution, more pain for the administrators, more pain for the security people. But if you have a one full platform that is basically going to do everything for you, I think it makes a lot of sense and it reduces the window of exposure in this scenario. So you can have multiple approaches, pattern search and analysis, of course, signature detection or writing signature patterns, heuristics, automated signature generation as well, policy and procedures, machine learning. Again, the message is very simple and clear. It's always going to be the hybrid approach. One thing is not going to lead to a substantial solution. So we talk about why there's a platform-driven approach is much more needed to actually go after, detecting and preventing cloud apps. So that being said, I think I'm pretty much done with the presentation right now, but we would love to have your questions if you have any, and then love to discuss and share the scenarios.
You think that as companies adopt more multi-factor authentication, it helps in these different scenarios, or does it just open up other avenues for exploring?
Yeah. So I think I'm just repeating the question again so that everybody on the same page. I think what we got the question here is like, implementing a multi-factor authentication solution is gonna help, or do we need additional things? Without a doubt, MFA is a very important thing where we get segregating the authentication channels, right? But The question is the problem is much more bigger than it. Most of like MFA you can prevent like account compromise and things like that. But when we look at the bigger threat models about a particular technology, it goes way beyond it. That's why always that we're going to give an answer is like hybrid approach, right? We need defense in depth strategies, right? People can still say, right, antiviruses are dead, but they are not. They are not. Okay, it has been reduced to certain sphere, but they are not. Firewalls, not dead. Every organization have it. How effective they are, that's a separate case, right? So nothing is 100%. So that's why security is always considered as a process, right? Defense and that. MFA, without a set, right? Even in my organization, people cannot have an account setting everything up without MFA, right? The alerts are set up in such a way that as soon as somebody does anything, it's going to trigger up, account will be locked down. So those things are there, but that's not entirely the solution, right? There's a multiple aspects to it. The way cloud apps are being exploited, then okay. It definitely helps, without a doubt. But there are much more to it as well in that case. I think there's one more question.
So extending the MFA, the AWS example that you gave over there, is it you probably don't use your main account, but you have the session token which expires every hour or something like that, so that you cannot, even if it gets compromised, it cannot be used. Is that correct?
I think it depends on the configuration. So again, let me reiterate the questions, because if you have an MFA in place, the way AWS accounts are being used, you can have tokens, but you cannot have like complete session enabled all the time with all the admin functionalities, and it is getting a bit restricted. Now I think it depends on the configuration. I can give you a very real case scenario, right? People who are doing quality assurance work, right, in the cloud, right? They have to do automation for regression analysis and things like that, right? When they build their automated code, right, the way they cannot use MFA in certain scenarios as well. One of the keys. And the importance that the complexity for them is way higher. So the way you design your defense and depth strategy, you want to make sure the few AWS accounts for that specific functionality is entirely segregated into the another environment. And the restrictions should be applied. We have seen some cases where that automation scenarios have led to bypassing of certain stuff and then resulted in running some unauthorized VPC instances and all that. But again, that depends on the configuration, right? If I go into a little bit more detail here, APIs like AWS APIs for all the IAM rules and all, at the end of the day, they need to have set up with the tokens as well. But how much it raises the complexity and everyone is on the same page, that matters at the end of the day. So I think security is all about, you cannot restrict because you have to find there should be a flexibility there, functionality there. That's why you go after multiple layers. And the more you sometimes go in, like your layer 7, for example, which is like go to the crux of your VPC, at that time you get a little bit relaxed as well. Like for example, how many guys are actually encrypting database connections inside the VPC? Because this is going to impact your latency. I'm just talking on several aspects here, so it depends, right? Where you have to get a little easier, where you have to get a little restricted. But defense in depth is the way to actually go. It's not perimeter only, just not only antivirus, just only one. There's more to it. Example, but you just cannot say that one technology is dead and then we are coming with the new. No, it's still there. People are still making billions of dollars because of firewalls. Therefore, I think there's one more question.
I have a question initially if an application which was initially for on-prem, right, it is now rewritten for the cloud, or it is extended to be used on the cloud also. Are there any tools the developer should be using to make sure that they don't have any obvious flaws which can be exploited?
I think, yeah, so I'm reiterating your question again. So because most of the applications being hosted on the on-prem, if they are actually being forced to go on to the cloud, what kind of tools are being used to actually strengthen the security posture of that cloud application? I think it's just not only a very direct answer to it, and the reason for that is, even in my organization, we have implemented a full process, right, a technical review process, right, which means that anything that is going on the cloud and have some external interfaces, those need to be reviewed upfront. When I say reviewed, is like the threat modeling is kind of a lot of things on there as well. And then what kind of additional processes you want to implement down the link. For example, you put your application in the cloud. What kind of TCP, UDP ports are opened while your security groups, and what kind of services are being exposed via that application component that is available on the internet. How effectively you are testing those, how often you are testing those, right? And then to get a clear idea, because one of the bigger problem when you go to the cloud is that it's so dynamic in nature with the load balancing and other kind of activities. Whatever the SaaS application you deploy, you need to host it on different production servers. But again, at the end of the day, the problem boils to the point is that the configuration changes very fast, right? People, like for security groups, right, how much ingress and egress filters you have deployed in the enterprises, right? And things like that. So it changes very fast. So in order to basically control that or manage that, there are tools available, but that is not only the solution. It's a full picture, full modeling of the component that needs to be done, and it has to be continuous. Otherwise, it's a tough target because somebody from like other team will come and spin the VPC instance and all that and open the ports, and you don't have that visibility. So now with the tools, yeah, you need to have some tools which call as like AWS monitoring tools, which actually gives you the idea how your AWS accounts are monitored. You need to deploy some, tools, for example, rootkit hunters and other kind of things in your production servers to give you the idea. And then you have to have, perform vulnerability assessment, penetration testing continuously in-house every month to get a feel of it, what it is all about. There's much more to it, but that's the whole sphere.
Is there any open source tools?
Yeah, there are many open source tools that can have. Like the one we talked about, the S3 bucket fuzzing, is an open source tool to that. And you can also write your own scripts as well, based on the search engines and stuff like that. So they are there for sure. All right, everyone. Thanks for attending the talk. Really appreciate that. Thank you very much.